All right, Chapter 3, Section 2.1, Part 1 video. In this section, they're going to be giving us some nonlinear equations. We're going to look at them, look how to solve them. You can actually solve this one by algebraic methods, the square root method, and come out with a solution. And I'm going to show you, but I don't recommend. I'm going to be showing you how to solve this on the calculator. So, but just for grins and giggles, I'm going to show you 9x squared equals 25. So divide both sides by 9. So I get x squared equals, jump the gun a little bit. All right, x squared equals 25 over 9. Folks, when you have an x squared or a squared term you want to get rid of, you take the inverse of it, which would be the square root. When you do that, know that you have two possible solutions. Okay, so the square root cancels the square, so that's equal to plus or minus. The square root of 25 is 5, and the square root of 9 is 3. So that's great if they're perfect squares like 25 and 9 are, but if the majority of them won't be like that, okay? So I'm about to show you how to do this on the calculator. Much easier than what having to relearn how to do that by hand on the algebraic techniques. So, all right, so we're going to go to y equals. We're going to hit 9x squared, and then we're going to hit 25 in y2. We're going to put left side in y1 and the right side in y2, okay? Now, we're just going to hit graph. I don't know what my limits are, but I'm just on my graph, so I'm just going to hit zoom 6, so it's going to put a nice little standard, right? And then I'm going to hit zoom fit, because I want it to kind of hit down here. Let's see. Let's do something real quick. I could do this a little bit easier. Let me hit zoom 6 again. Yeah, okay, and then zoom fit. Alright, so what I'm going to do is, I guess I could do it a little easier right here. If I go to window, and you see that my Y max is 900, and I'm drawing a horizontal line at 25, I only need about maybe up to 40. And then a Y min, I'll put negative 10, and then hit graph. Alright, so I changed those just based off of knowing that I got a horizontal line at 25, and it really put my limit up at 900. So that's a good thing on some things, but not when I'm wanting to show you some stuff on this. So we got to find where it intersects, right? So we have two places where it intersects. So second trace, hit number 5, and we're going to move our cursor. Okay, and I always put it, if we're moving on the x-axis from left to right, the cursor, I'm always putting it so that it runs into what I'm going to be intersecting. So that's why I put it up top or above the red line on this one. So enter, 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 and enter. And you can see that it is negative 1.67. So that's one of my answers. Second trace again. Hit number 5. Now I'm going to move it over. And this time, as I'm progressing, I'm going to leave it underneath it, so that because it's going to run into it, right? I want to always make sure that I'm running into it. That's just something that I do. You get it close to it, it'll find it, okay? So enter, 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 and I get positive 1.67. So for this particular answer, we actually have plus minus 1.67. Now it says solutions separated by comma, so I put a 1.67 comma negative 1.67. Okay, or vice versa, put negative first. Okay. Now let's look at another one. And from here on out, I'll be solving these on the calculator, because again, guys, this is Math 1101. It's a modeling class, so I'm not going to go through a lot of algebraic techniques. Okay, we can solve it on the calculator. We're going to solve it on the calculator. All right, so same thing here. On this one, all of it's setting on the left-hand side with a 0 on the right. That's okay. 36. So I'm going to hit clear, go to y equals and clear those out. Go back to my, no, I don't want that. I want this one. 36x squared minus 24. So 36x squared minus 24. And then I'll put 0 in y2. Now, I just want to double check that. Let me X out of that real quick. Yeah, 36x, okay. Alright, so I'm just going to hit graph. Okay, so the limits I had just a while ago are good. So we're going to find where it intersects at this first point, where it hits the red, and then over here. So what we're going to do, again, is second trace, number 5, and we're going to move my arrow, and if you'll look at your y values, you can kind of see where it is. So I need to go back the other way. There we go. So I'm going to hit enter, enter, enter. So I get negative 0.82. Okay. Go back to this one. Now I'm going to move it over. Oh, sorry. Second trace 5. Now I'm going to move it over. I was just hitting the trace button, and that's not good. Okay, so I've moved it up right at the intersection of that. Enter, enter, enter. And that's a positive 0.82. Okay, so that makes it solving a whole lot easier. Okay. All right, so let's look at another one. A conical coffee filter is 8.4 centimeters tall. Write a formula. All right, so you got to know that a cone is pi r squared h over 3. So it tells you that its height is 8.4 centimeters tall, right? So we're going to replace 8.4 in for h. Write a formula for the filter's volume in terms of its widest radius. Yeah. Okay. So they just want us to do this. Pi r squared times 8.4 all divided by 3. Now, so that's our equation. What we're going to do is we're going to take it and we're going to put it inside of our calculators. So I'm going to go here, clear out some stuff. Clear. There's a pi button right over here. Second pi x squared 8.4. Well, I should have done that. Let me hit clear. Okay, let me hit parentheses. Let me hit this because I messed up. Parentheses, right? Pi times x squared times 8.4 close parentheses divided by 3. And I'm pretty sure that's what we had, right? Yep. Now, what we're going to do is we're going to go to second window, and it's asking me. I've got my ask, so I can put in x values as opposed to letting it generate a table. So I'm going to go second table. If I have anything there, I'm just going to hit delete. So 1, 2, 3, and 4. So I can do that real quick. So 1 enter, 2, enter, 3, enter, 4, enter. And you can find what the volume is based off of that. If the radius was 1, 2, 3, or 4. So that answers the first couple of questions, okay? So that's where these will go in. If there's any more, you can put those in, right? All right, so let's look over here. If you double the radius of the filter, the volume increases by a factor of what? Well, let's look at it. Well, we could either use 1 and 2 or 2 and 4. So if you got your calculator, very quickly see, well, you can do 100, let's see, we'll do 2 and 1, so 35.19 should be, hold up, 35.9 divided by 8.8 should be 3, that comes out to be 3.998886, which is 4. And we'll show you how to know that. If you double it, the radius goes up by a factor of 4. So that's what we're going to do there. If the volume of it's 305.2, what's radius? Okay, so we've got 305.2. That's an output. They want to find the radius, right? So I just put that in, and I'm going to hit graph. I don't have a clue where it is. So I'm going to hit zoom 0, and I'm going to say, hey, fit it, right? So there's going to be a negative one over here and then a positive one over here. And what do I mean by negative? The x values over here at this intersection are negative. The x values over here are positive. And of course, distance can never be negative, so therefore we will always choose the one that's positive. So we'll look for its intersection, okay? So I'm just going to move it, moving it over. Again, all I'm doing is just getting it up there close. Enter, 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 and I've got 5.89. Okay, so the radius would have to be 5.89, and we've already graphed it. So this is chapter 3, section 2.1, part 1.